Hello everyone. Today we are going to start with our new topic, sliding window. And yes, it is like a very good topic. It will help you very much in reducing the time complexity of this code. And we will just learn how we can identify questions of this type and what are the types of this question, isn't it? So yeah, first of all, from where the idea of sliding window came? Let's see. Let's suppose I have an array something like this. Let's suppose I have an array 1, 2, 4, 7, 2, 1, 3, 4, something like this, any random array. Now, let's suppose I tell you that you return me the sum of all the subarrays whose length is 3. Let's suppose this is the task which you need to handle. So what you will do is you will start from the beginning. Okay. You will take the subarray of length 3. You will get sum as 7. You will return me 7 as one of my answers. Then you will again go to 2. You will calculate 2 plus 4 plus 7. You will just run a loop which will run 3 times, and you will just calculate the sum 2 plus 4 plus 7, and we will get 13. Now you will come to 4. You will again run the loop 3 times, and you will get the answer as 7 plus 4 plus 2, which is 13 again. So and so on. You will come to every index and run the loop 3 times if it's possible. So what's the time complexity of this code? If I ask you the time complexity of this code. So one by one, you are coming to every index, right? So for every index, you're running the loop. In this task, you are running it 3 times. So let's suppose there is an array of size n. And I tell you to find the sum of all the subarrays whose length is m. So what do you think that the time complexity of this code will be? So according to me, it will be big O of n multiplied by m. Isn't it? Like for every index, we are running the loop m times, right? हर इंडेक्स के लिए m टाइम्स लूप रन कर रहे हैं ना. अगर हमें m साइज का सब एरे चाहिए तो m साइज के सब एरे का सम चाहिए तो we are doing that. Now, yeah, we are doing the repetitive work. See how we are calculating over here 1 plus 2 plus 4, and again we are calculating 2 plus 4 plus 7. This 2 plus 4 is calculated before and we are not using it. ये तो ऐसा ही है ना कि हमने पैसा जमा कर लिया, बट अब अगर उसको लाइक खर्च करना है तो नया से बार बार अर्निंग कर रहे हैं. वी आर नॉट लाइक यूजिंग द मनी वी सेव्ड, इजंट इट? सो या, दैट्स नॉट एक्सेप्टेबल, राइट? टाइम भी लग जाएगा इसमें बहुत, एंड यू विल गेट टीएलई. सो हाउ टू यूज दिस इंफॉर्मेशन? लाइक 2 plus 4 वी हैव कैलकुलेटेड, हाउ टू यूज दिस? ये सही है ना, यूज करना आना चाहिए. यूज ही नहीं करने आता देन प्रॉब्लम है. So that we will learn in our topic, sliding window. And I am just going to explain you in brief the approach, and we will gather much better information in the coming videos. So yeah, let's just look how we will handle in this case. Like 1 plus 1, 2, 4, 7, 2, 1, 3, 4 is our array. So let's write down the array once again. 1, 2, 4, 7, 2, 1, 3, 4. Okay. So what we will do is, let's suppose in this question we are told to find the sum of subarrays, all of length 3. So what we can do is, we can keep one of our starting index over here. Like let's say I'm denoting my starting index with I, and I can keep my ending index over here. Now what I will do is, I will run the loop in J. Okay, I will run the loop in J. So what I will do is, for till where my j can go till the last index. So while j less than n. Okay. Now what I will do is, whenever I am in any index j, I will take the sum in that. Let's keep a variable sum, initially 0. Okay. Now I am in 1. I am in index 0. So what I will do, I will take this sum. Okay. I will take this sum. I took 1. Now what I will check is, what is the size of the window whose sum I have taken. So like the window starts from I, the window ends at j. So what is the size of the window? The size of the window is j plus Let me just write it down. What is the size of the window? The size of the window is j minus I plus 1, isn't it? If your window starts at I and ends at j with both I and j included, then the size of the window will be j minus I plus 1. So we will keep a check that if j minus I plus 1 is equal to the required size of window, if j minus I plus 1 is equal to the required size of window, let's suppose the size of the window is k, then if it's equals to k, what we will say? We will say, yeah, this is one of our possible answers. Like the sum we have got till now is one of our possible answers. So what you will do is you will store this sum. Like we need to return every sum of subarray k, isn't it? So yeah, we can store this sum. Like let's maintain an answer vector. And what we can do is we in answer we can push back this sum. I hope till here it is clear. Okay. So now let's suppose and you will do simply j plus plus to move to the next index. So what will happen? When you will take the sum of 1, 2 and 4 from the starting, your this condition will get satisfied and yeah, you will push back the sum 7 in your answer vector. Okay. Now when your j shifts over here, initially your I is there. Just remember this, your I is over here. Now when your j shifts back over here, you add that sum in your sum, that nums of j you add it in your sum. So your sum till here was 7 and when you add 7 it comes 14. Okay, now the sum is 14. But what is the size of window? Just tell me, what is the size of window? Your j is over here, so j is equals to 3 and I is over here, so therefore I is equals to 0. So what is the size of window? It is j minus I plus 1, which is nothing but 4. But what was the maximum, like what was the size of window required? 3. So what we can do is, we can shift our window, that is we can shift our I from here to here, isn't it? But one thing which we need to keep in mind is, when we are shifting our I, so we have included this value in our sum. So while shifting, we need to subtract this value from our sum variable. So yeah, before doing j plus plus, what we can do is, we can just keep a check that if j minus I plus 1, that is the size of the window, if it is greater than k, that is the required size. So we will just run a while loop for shifting I, like while j minus I plus 1 is greater than k, what we can do is we can subtract that ith value from our sum because we have included it and we can shift our I, isn't it? This is the thing we can do. And after this, we can just, like we know, like after this operation, our window size, that is j minus I plus 1, will be equals k. So we can store our answer in our vector answer. Like the sum, we can push back sum in our answer vector. So if we don't need to do this step, we can just keep a check that if j minus I plus 1 is greater than k, then we will do this. And after that operation, we will push this. And if it is not so, like if j minus I plus 1, that is the window size is less than k, then we need to do nothing, right? We will do nothing in this case. Because पहले तो k size का window तक तो पहुंचना होगा ना. अगर पहले k size का window तक ही नहीं पहुंच रहे, then तो problem है. First we need to reach the size of window k. And then we will start these things, right? So yeah, और एक एग्जांपल लेते हैं, उससे और क्लियर हो जाएगा. Let's suppose array is this, and I say you that you return me the sum of all subarrays with window size 3. So what you will do is, just see the steps. I have initialized my I over here. I have initialized my j over here. I will keep a sum variable. Now whenever I come to any index j, I will add that element to the sum. So I add 1, j shifts over here, I add 2, j shifts over here, I add 4. Now, when j shifts like now j shifts over here, I at 4. Now check the window size. Is the window size equals k? In this case, k is equals to 3. So is the window size equals k? Yeah. The window size is equals to k. So this is the possible answer. So we can just store our sum over there. Now when you shift your j over here and you check the window size, it exceeds the value k. k value को तो पार कर गया ना, window size 4 हो गया है. So क्या करना होगा हमें? हमें इस I को इधर shift करना होगा, isn't it? So while shifting I, the one thing we need to keep in mind is we have stored 1 in our sum, like we have added 1 in our sum. So 1 को subtract कर देना होगा बस. 1 को subtract करके I को shift करो. So I shifts over here and 1 gets subtracted. So just basically when you came to J, you added 3, and while shifting I, you subtracted 1 from here. And the sum you will get is this sum, this window. Similarly, when you shift your j over here, so again window size will exceed because this is the window size which will exceed the value of k. Again you will shift your I. Now when you shift your I, the window will represent this. So देख रहे हो हम लोग बार बार वो like 4 plus 3 if we have calculated before, we are not calculating it again. वो दिमानी का चीज कर रहे हैं ना, 4 plus 3 बार बार calculate नहीं करते. If we have 2 plus 4 plus 3 and we are adding 6 in that and the window size is exceeding the required window size, then we are just shifting our 2. Like we are just removing 2 from our window because we have included a new member, isn't it? Like अगर मैं आपको बोलूं कि आपके पास 6 लोगों का जगह है, okay? If you have a place where 6 people can accommodate and like you are following an algorithm first come first serve. So what you will do is like not first come first serve, you can say something like this. New one is given priority. Like the new person is given the priority. So you like one person came, you kept him over here, another, and another. Now you have like completed the size. Now let's suppose one another person came. So what you will do is you will tell this person that हाँ आप बहुत पहले आए थे, अब आपका निकलने का समय आ गया है तो निकल जाओ, क्योंकि हमें नया पर्सन को यहाँ पे घुसाना है, isn't it? So yeah, before removing this person, let's suppose this person was doing some job 1, this was 2, 3, 4, 5, 6, and you are just calculating the sum of the jobs. So like what is the sum over here? It's nothing but 21. So yeah, and new person came with job 7. So what you will do is before removing this person, ये person जितना contribute कर रहा था उसको तो हटाना होगा ना. We need to remove the contribution of this person, right? So yeah, we will remove that from our sum, that is 21 minus 1, which will be 20, and we will take the job of new person, that is 20 plus 7, which is 27. So this is the method we follow, and like this is a very good approach of sliding window. यहाँ से time बहुत कम बच रहा है, like time बहुत बच रहा है. It's saving our, like it will remove our code from big O of n multiplied by k to only big O of n, isn't it? Like अगर k size का सब array के लिए हम लोग को कैलकुलेट करना था, so instead of going to every index and running the loop again and again k times, what we can do is we can just shift one element and do the same thing in big O of n time complexity. So yeah, this is the approach, this is the like thinking behind sliding window. We will see like there are 2 types of sliding windows. We can see that we will see in the coming videos. For this we can stop over here and let's meet in the next one. Thank you.